Good afternoon. 20 EC 607 LEL Internet of Things Laboratory. Now we are going to see the second experiment, simulation of ultrasonic sensor. So previously we have discussed that simulation of blinking LED and also the DC motor and how to write the program. That and all we have seen in the last class. Okay, so how your pick and place directly from that your schematic block and how we are using a normal connection in this particular experiment we have discussed that. So now we are going to see the second experiment, simulation of ultrasonic sensor interfacing with the Arduino using Tinkercad. So the previous option what I have told, the same thing, you just Google Tinkercad, go to this Tinkercad, create 3D digital designs with online CAD, click this website. Go to login in the corner of the site, so and click the educators. You have to use a Google account. All must have an individual Gmail account here, then only you need to practice there. So click the second option, sign in with Google. So I already having this Google account here, it will be redirect to that particular Tinkercad website. It takes a time here. So you need to understand that clearly, that your entire concept of connecting this, so you have to practice daily only. This will be automatically has to be understand clearly. So what is the option next one? You have to click this new design and then you have to create a circuit here. It will be redirect to that schematic blocks. So you have a right hand side, you having a entire components by clicking this basic and then Arduino like that. So the second experiment is a ultrasonic sensor. You just click Arduino here. So where is that ultrasonic sensor here means, so here there is a ultrasonic sensor by connecting into that Arduino board. By click this and drag and place this experiment in the schematic block. So you have to change your experiment's name also, rename it into the left hand side of your corner, simulation of ultrasonic sensor. Just rename it. Yes, it has renamed clearly. Okay, so here the connection is very simple. You have to use this Arduino board. So what is your aim of this experiment? To simulate the ultrasonic sensor with Arduino using Tinkercad, and then apparatus required is Arduino board and then your ultrasonic sensor. That's it. You need to write also your Tinkercad website also. Okay, next procedure, you have to write that, go to the Tinkercad website and link with the Gmail account. Second one, go to the new designs and then click to create a circuits, and automatically it direct to the entire schematic block here, and then what is the you have to go using here means you have to create a design of your corresponding experiment. Now we are going to see your code here. By clicking the code, you just go to the text. So here there is an entire program of this ultrasonic sensor. So before that, what is the connection they are using? That means, so here there is a 3-pin ground, and then your power, and then your signal. So ground connection here in your Arduino board having a 3 ground connection wherever you want, or else you're free to place, or you just easily to connect that. So here there is connected in this particular ground connection. Next to 5 volt. So 5 volt means you just going to be connecting this 5 volt only, not in 3.3 voltages. And then signal, you just connecting the wherever you need to connect this particular digital pins. Here there is connecting in that 7th digital pin. So go to code, see that experiment. So what is the basic of your ultrasonic sensor? What is the purpose of that ultrasonic sensor? It is to be identify that object of the distance. So distance in the sense, either you have to mention as a centimeter and also your inches here. So by understanding this, you have to mention this globally int inches, int centimeter, defaultly 0. And then what is that you are going to mentioning here? This is also you are mentioning that your globally. So what is that? Long read ultrasonic sensor, in trigger pin and in echo pin. So in trigger pin is your output pin mode, and then so this trigger pin first defaultly it will be a off conditions, and after a microseconds it will be a high positions, and also your echo pin is a input connection here. So now we are going to see entirely into that setup. So this setup is going to be used as a baud rate. So baud rate range is 9600. So why you are using this baud rate means the connection with you are going to use that how fast is going to be enabling that. And then your loop connections. So you have to remember this centimeter calculations. Okay. So the centimeter calculations 0.01723 into read ultrasonic distance from your pin connection, 7th pin. Okay. So inches, how much centimeter has come here, divided by 2.74. You have to print here and show that in and also centimeter here. So likewise your program will be enabling here. So by using that echo pin, so that particular distance it automatically just analyzing that, and then simultaneously your trigger pin will be automatically functioning here. So this output you are going to see in this serial monitor and also your toggle graph. So you just click this start simulation. See that your program by clicking this. So you're defaultly having a 44 inches corresponding 113 centimeter. I just move on to that your experiment. So this ball I'm going to just say deviate that your distances. Now the distance is 116. You just go to click here. So 116 centimeters only here. See your graph. So by adjusting that your graph also will be functioning here. So I just keep as a constant, your graph will be automatically going to the same positions that defaultly, and after I just click the by adjusting here and there, you just go and see here. So your value will be automatically changing here. So now 73 inches 187 centimeter, and then your graph is going to be used here. So by adjusting the position, your graph also will be automatically coming like this. Okay, it is not going to be a sine wave or else. So what distance I just used, that it will be automatically placing that corresponding graph also. Okay, so that's all of your experiment. It's successfully verified here. Thank you.